The afternoon of January 11th, 1944, over Oschersleben, Germany, presented what Luftwaffe pilots had learned to recognize as a manageable problem. American heavy bombers droned overhead in their combat boxes, B-17s and B-24s, maintaining tight formation at 23,000 feet. Their Fortress and Liberator crews were experienced now, disciplined, their defensive fire coordinated and deadly. But the Luftwaffe had developed tactics to handle this. What made this day different, what would fundamentally alter the air war over Europe, was something the German fighter pilots couldn't yet see. Something hanging beneath the bellies of the American escort fighters that would, for the first time, deny the Luftwaffe their most reliable tactical advantage: time. Oberleutnant Franz Stigler of Jagdgeschwader 27, flying his Focke-Wulf 190, understood the rhythm of these battles. The American fighters, P-47s mostly, would arrive with the bombers. They would engage for perhaps 20 minutes, maybe 30 if they were disciplined about throttle settings. Then their fuel zhuang tai would force them to break off, turn back toward England, and leave the bombers to defend themselves. That was when the real work began. That was when Luftwaffe pilots could press home their attacks without worrying about the escorts. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. On this January afternoon, Stigler and his squadron mates climbed to intercept altitude, watching the contrails of the American formation crossing into German airspace. They had fuel for perhaps 90 minutes of combat flying. More than enough. The Americans would be gone long before that, except this time they weren't. The P-47s stayed. They stayed through the initial engagement. They stayed as Stigler's Gruppe made their first firing pass. They stayed as the bombers reached their target and turned for home. And they stayed, impossibly, as the Luftwaffe pilots who had burned their fuel in combat had to break off and return to base. Something had changed. The Americans had brought something new to the battle, something that appeared deceptively simple. 3 large teardrop-shaped metal tanks, one under each wing and one under the fuselage of each fighter. Drop tanks, external fuel tanks that could be jettisoned when empty or when combat required maximum maneuverability. The technology wasn't new. The decisive application of it was. What the Luftwaffe pilots discovered that afternoon was that the fundamental equation of the air war had shifted. The Americans could now stay. They could loiter over Germany for hours, not minutes. They could escort the bombers all the way to the target and all the way home. The tactical advantage that had allowed the Luftwaffe to remain a potent defensive force despite overwhelming numerical odds. The advantage of knowing the Americans had to leave had evaporated. The psychological impact of this realization would prove as significant as the tactical one. For months, German fighter pilots had structured their entire approach to bomber interception around the certainty that escort fighters had limited range. Every tactical decision, every attack profile, every calculation of risk versus reward assumed that patience would eventually isolate the bombers. That assumption was now obsolete, and the men who had built their survival strategies around it would have to fundamentally recalculate what it meant to defend German airspace. To understand what changed on that January afternoon, one must understand the mathematics of fighter range and the doctrine it produced. The Republic P-47. Thunderbolt that entered service in 1943 was a formidable aircraft. It weighed 7 tons empty, could reach 413 miles per hour in level flight, and could climb to 30,000 feet. Its 850 caliber machine guns, 4 in each wing, carried a total of 3,200 rounds. The aircraft could absorb tremendous battle damage and bring its pilot home. It was, by any measure, an excellent fighter, but it had one critical limitation: range. The P-47's internal fuel capacity was 305 gallons, carried in 6 self-sealing tanks distributed throughout the fuselage. At combat power settings, with the Pratt & Whitney R2800 engine consuming fuel at high rates during climb, combat maneuvering, and high-speed flight, the aircraft's effective combat radius was approximately 175 miles. This meant that from bases in England, a P-47 could escort bombers to roughly the German border, engage in perhaps 20 minutes of combat, and return home with minimum fuel reserves. The Luftwaffe understood this equation precisely. Their intelligence services tracked Allied fighter deployments, calculated fuel consumption rates, and produced range circles on operational maps. German fighter commanders knew exactly where American escorts would have to turn back. They briefed their pilots accordingly. Avoid engagement with escorts when possible. Wait for them to reach their fuel limits. Then press attacks against the bombers themselves. This doctrine had proven effective throughout 1943. The 8th Air Force lost 690 bombers that year, primarily to fighter attacks. The loss rate on deep penetration raids to targets like Schweinfurt and Regensburg approached 20% of aircraft dispatched, unsustainable casualties that threatened the entire strategic bombing campaign. The bombers needed continuous fighter escort to survive, but the fighters couldn't reach the targets. The mathematics of fuel and distance created what military planners called the range problem, and solving it became the highest priority for Allied air commanders in Europe. The solution, in concept, was straightforward: carry more fuel. External fuel tanks had existed since the early days of aviation. They were simple in principle: metal or paper tanks attached to external hard points on the aircraft, connected to the fuel system through quick disconnect fittings, droppable when empty to reduce drag and weight. But implementing this solution at the scale required for strategic bombing escort involved challenges that took months to overcome. Manufacturing capacity was the first hurdle. Building millions of gallons worth of drop tanks required factories, materials, and workers that were already strained supporting the massive expansion of Allied air power. The tanks themselves, while simple, had to meet exacting specifications. They needed to feed fuel reliably at high altitude where temperatures reached 40 degrees below 0 Fahrenheit. They needed to withstand the aerodynamic loads of 400-mile-per-hour flight. They needed quick-release mechanisms that worked reliably in combat. And they needed to be produced in quantities sufficient to equip every escort fighter on every mission, because the tanks were not reusable. Once dropped, they fell away, lost somewhere over Europe. American industry rose to this challenge with characteristic efficiency, but it took time. Initial production of pressed metal tanks proved inadequate to meet demand. Engineers developed paper tanks, constructed of layers of treated paper, formed into teardrop shapes and sealed with chemical treatments. These disposable tanks could be manufactured quickly and cheaply, though they were fragile and sometimes leaked. By late 1943, production had ramped to a level that allowed systematic equipping of P-47 units with external tanks, typically 2 75-gallon tanks under the wings and 1 75-gallon tank under the fuselage, for a total of 225 gallons of additional fuel. The Luftwaffe's confidence in their tactical approach to bomber interception was not arrogance. It was the product of careful analysis, combat experience, and rational calculation. German fighter pilots in 1943 and early 1944 were among the most experienced combat aviators in the world. Many had flown in Spain during the Civil War, in Poland, in France, in the Battle of Britain, and on the Eastern Front before being rotated to Reich defense duties. They understood air combat at an intuitive level that came only from hundreds of hours of actual fighting. The Focke-Wulf 190 that equipped many Luftwaffe day fighter units was an exceptional aircraft, arguably the finest fighter in Luftwaffe service. Designed by Kurt Tank and entering service in 1941, the FW-190 represented a different design philosophy from the Messerschmitt Bf 109. Where the 109 was light and nimble, the 190 was robust and powerful. It used a BMW radial engine, the 801D model, producing 1,700 horsepower for takeoff. The radial configuration made the aircraft less vulnerable to damage than inline engine fighters. A few bullet holes in the cylinders would reduce power, but rarely caused catastrophic failure. The 190's armament was devastating. Standard configuration included two 13mm machine guns in the upper engine cowling, synchronized to fire through the propeller arc, and four 20mm cannons, two in the wing roots and two in the outer wing panels. Some variants carried 30mm cannons for anti-bomber work, weapons that could destroy a B-17 with a single well-placed hit. The aircraft could reach 408 miles per hour in level flight, climb to 20,000 feet in under 10 minutes, and could outroll any Allied fighter at high speeds. American pilots who faced the FW-190 learned to respect it immediately. Luftwaffe pilots flying these aircraft had developed specific tactics for engaging American bomber formations. They attacked in groups, called Sturmgruppen, when specifically organized for bomber destruction, approaching from head-on when possible to minimize their exposure to defensive fire. The closing speed in a head-on attack, combined with the limited time bomber gunners had to track and engage, made this the preferred attack profile despite the difficulty of achieving hits. Alternatively, they attacked from high rear quarters, diving through the formation, firing, and using their speed to escape before escorts could engage. The key to all these tactics was timing. German controllers, using radar and observer corps reports, tracked incoming raids and vectored fighters to intercept points. The fighters would climb to altitude, position themselves relative to the bomber stream, and wait. Wait for the escorts to reach their fuel limits and turn back, then attack. This patience was not passive. It was an active tactical choice based on accurate understanding of American fighter capabilities. Why waste fuel and ammunition fighting escorts when those escorts would inevitably have to leave? Why accept the risk of combat with P-47s when 20 minutes of patience would eliminate them from the equation? This doctrine had worked. Through the autumn of 1943, Luftwaffe fighter units defending German airspace had maintained a kill ratio that, while unsustainable in the long term due to the disparity in resources and replacement rates, demonstrated tactical effectiveness. They shot down more aircraft than they lost in most engagements. They forced the Americans to pay a terrible price for every raid. They knew they couldn't win the war this way, the numbers were too lopsided. But they could make victory expensive enough that perhaps the Allies would negotiate rather than continue the grinding attrition. What they didn't fully account for was American industrial capacity, applied specifically to solving the range problem. The drop tanks that began appearing in quantity in late 1943 and early 1944 represented more than just additional fuel. They represented a systematic approach to eliminating the Luftwaffe's tactical advantage through mass production and technological application. The Germans knew about drop tanks. They had seen them before. What they hadn't fully grasped was the scale at which the Americans would deploy them, or how decisively that deployment would shift the balance of the air war over Europe. The technical challenge of extending fighter range through external fuel tanks required solving problems that appeared simple on paper, but proved complex in execution. Republic Aviation, manufacturer of the P-47, worked closely with the Army Air Forces to develop drop tank systems that would function reliably under combat conditions. The engineering specifications were demanding. The tanks had to withstand aerodynamic loads at speeds exceeding 400 miles per hour, function at altitudes above 30,000 feet, where temperatures dropped to minus 40 degrees Fahrenheit, feed fuel consistently despite changes in pressure and temperature, and release cleanly when jettisoned without damaging the aircraft or disrupting flight characteristics. The 75-gallon pressed metal tanks that equipped P-47s in early 1944 represented the culmination of months of testing and refinement. Each tank was formed from sheet metal, typically aluminum or steel depending on material availability, shaped into a teardrop profile that minimized drag while maximizing internal volume. The tank attached to the aircraft through a pylon mount that incorporated both the structural attachment and the fuel line connection. A spring-loaded latch held the tank in place. Pulling a release handle in the cockpit would open the latch and allow the tank to fall free. The fuel system integration required careful engineering. External tanks fed into the aircraft's internal fuel system through a one-way valve that prevented backflow. Pilots had to manage fuel consumption carefully, burning external fuel first before switching to internal tanks. This sequencing was critical. If combat erupted while flying on external tanks, the pilot needed to switch to internal fuel, drop the external tanks to reduce drag and weight, and then engage. The process took seconds, but those seconds could mean the difference between life and death in a high-speed engagement with Luftwaffe fighters. Production of these tanks consumed enormous resources. Each pressed metal tank required approximately 15 pounds of aluminum or 20 pounds of steel. Manufacturing 1 million tanks, enough to support sustained escort operations, would require 15 million pounds of metal, equivalent to the material needed for roughly 300 B-17 bombers. The Roosevelt administration made this allocation despite competing demands from every other weapons program, recognizing that solving the fighter range problem was essential to the survival of the strategic bombing campaign. Paper tanks offered an alternative that reduced metal consumption. These tanks, manufactured from layers of treated paper molded into shape and sealed with waterproof compounds, could be produced more quickly and cheaply than metal tanks. A paper tank weighed approximately 8 pounds empty compared to 15 pounds for an equivalent metal tank. The weight savings meant slightly better aircraft performance, and the reduced material requirements meant higher production rates. But paper tanks had drawbacks. They were fragile, sometimes leaked, and occasionally failed to feed fuel properly at high altitude. Pilots had mixed feelings about them, appreciating the additional range they provided, while remaining skeptical of their reliability. By January 1944, production had reached sufficient levels to equip every P-47 on escort missions with external tanks. Typical loadout was 2 75-gallon wing tanks and 1 75-gallon belly tank, though configurations varied based on mission requirements and tank availability. With 225 gallons of external fuel added to the 305 gallons of internal fuel, a P-47's total fuel capacity reached 530 gallons. This increased the theoretical range dramatically, though actual combat radius depended on numerous variables including altitude, speed, combat maneuvering, and weather conditions. The mathematics of fuel consumption at combat power settings were unforgiving. The R-2800 engine burned approximately 270 gallons per hour at maximum continuous power, the setting used during combat. At cruise settings, consumption dropped to approximately 80 gallons per hour. A mission profile might include 30 minutes of climb at high power, 90 minutes of cruise to the target area, 30 minutes of combat at maximum power, and 90 minutes of cruise returning home with a 30-minute reserve for emergencies. The external tanks provided the margin that made this profile possible, extending the P-47's combat radius from 175 miles to approximately 325 miles, enough to escort bombers to Berlin and back. Training pilots to manage this increased complexity took time. Fighter pilots had to learn new procedures for external tank management, understand the aircraft's changing flight characteristics with tanks attached, practice emergency jettison procedures, and develop judgment about when to drop tanks and when to retain them. Early missions with drop tanks revealed problems. Tanks that wouldn't release, fuel that wouldn't feed, pilots who forgot to switch to internal fuel before combat and found their engines quit at the worst possible moment. These issues were gradually resolved through improved training, better procedures, and equipment refinements. The mission order for January 11, 1944, designated Oschersleben as the primary target, a town in central Germany approximately 120 miles west of Berlin. The target was the AGO Flugzeugwerke aircraft factory, producing WWII fuselages and components. Intelligence estimated the facility's destruction would impact German fighter production by approximately 10% for several months. It was exactly the kind of target the 8th Air Force had been tasked to destroy, infrastructure supporting the Luftwaffe's ability to defend German airspace. 263 heavy bombers launched that morning from bases across eastern England, forming into combat wings and climbing to bombing altitude. The 1st Bombardment Division contributed 174 B-17s, while the 3rd Bombardment Division provided 89 B-24s. Weather over England was marginal, with cloud layers that complicated formation assembly, but conditions over the target were forecast to be clear, allowing visual bombing. The bombers carried a mixed load of 500-pound and 1,000-pound high-explosive bombs, enough to devastate the factory complex if the bombardiers could place them accurately. Escort for the mission included elements of the 4th, 56th, and 78th Fighter Groups, all equipped with P-47s. Each fighter carried 3 drop tanks as briefed, the maximum fuel load possible. Pilots had been told this would be a deep penetration mission, that they would stay with the bombers longer than ever before, and that they should not assume the Luftwaffe would wait for them to leave before attacking. The briefing emphasized fuel management. Burn externals first. Don't wait until they're completely empty to switch to internals. Drop tanks immediately if engaged, and remember that you now have endurance to loiter over the target area. The formation crossed the Dutch coast at 10:42 hours, bombers maintaining their combat box formations at 23,000 feet. Fighters stepped up at 25,000 feet, in positions covering the bomber stream's flanks and high rear quarter. German radar detected them immediately. Luftwaffe controllers began vectoring fighter units to intercept positions, following standard procedures developed over months of defending against American raids. The controllers calculated intercept points based on the bomber stream's speed and heading, and more importantly, based on when they expected the American escorts to reach their fuel limits and turn back. Jagdgeschwader 1, flying from Diemen in Holland, scrambled 42 FW-190s. Jagdgeschwader 11, based at Höchstadt and Rotenburg, launched 38 Bf-109s and FEW-190s. Additional units scrambled from fields across northern Germany. The Luftwaffe put up approximately 250 fighters that afternoon, a massive response that reflected both the importance they placed on defending industrial targets and their confidence in their ability to inflict serious losses once the escorts departed. The first contacts came at 11:05 hours as German fighters positioned themselves at a distance from the bomber formation, climbing to altitude, waiting. American fighter pilots saw them, reported their positions, but did not immediately engage. The tactical doctrine was clear. Stay with the bombers, don't be drawn off by feints, conserve fuel, maintain position. The Luftwaffe fighters circled, watching, waiting for the Americans to turn back. It was a familiar dance, one both sides had performed dozens of times. The Americans would stay as long as they could, then fuel would force them home, and then the real battle would begin. Except at 11:30 hours, when by all previous experience the P-47 should have been turning back toward England, they remained. At 11:45, still there. At noon, as the bomber stream approached Oschersleben and began its bombing run, the American fighters were still in position, still covering the formation, showing no signs of fuel exhaustion or departure. German fighter pilots, flying patterns at a distance from the bombers, watched with growing confusion. Their fuel was burning. They couldn't wait indefinitely. But engaging the escorts would mean fighting the very aircraft they had planned to avoid, and fighting them while the Germans themselves were now becoming fuel critical. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Luftwaffe attack, when it came, was hesitant and disjointed compared to the coordinated assaults German fighters had executed on previous missions when escorts had departed on schedule. Some units attacked anyway, accepting combat with P-47s because the bombers were over the target, and this was their last opportunity. Other units held off, hoping the Americans would finally leave. Some German pilots, critically low on fuel from their time at altitude, had to break off and return to base without engaging at all. The entire tactical structure that had made the Luftwaffe's defensive operations effective had fractured because the fundamental assumption underlying it, that American fighters had to leave, was no longer true. Oberleutnant Heinz Knoke of Jagdgeschwader 11, one of the Luftwaffe's most experienced bomber defense pilots, recorded his reaction to that day's mission in his diary, later published as "I Flew for the Führer." He wrote about seeing the American fighters still present over the target, still present during the withdrawal, and feeling something close to despair. The mathematics had changed. The tactical advantage that had allowed outnumbered German fighter units to remain effective through selective engagement had disappeared. Now they would have to fight the escorts, fight them over Germany, where the Americans had numerical superiority, fight them while trying to also attack the bombers, and do it all knowing the Americans could stay as long as their fuel lasted. The mission results reflected this disruption. The bombers hit the AGO factory with reasonable accuracy, dropping over 500 tons of bombs that destroyed approximately 40% of the facility. More significantly, bomber losses were relatively light. 5 B-17s and 1 B-24 failed to return, a loss rate of just over 2%. Previous missions to similar targets had suffered losses exceeding 10%. The difference was the continued presence of escorts that forced the Luftwaffe to fight at a severe disadvantage or disengage entirely. American fighter pilots returned to England with a new understanding of what was now possible. Captain Don Blakesley of the 4th Fighter Group, one of the most aggressive fighter leaders in the 8th Air Force, landed with fuel to spare after nearly 4 hours in the air. His aircraft had flown to Oschersleben, engaged multiple German fighters, escorted the bombers during their withdrawal, and returned to England with 30 minutes of fuel remaining. The drop tanks had worked exactly as intended. The range problem, which had seemed insoluble just months earlier, had been solved through the simple expedient of carrying more fuel in disposable tanks. The psychological impact on Luftwaffe pilots was profound and immediate. They had built their entire defensive strategy around time. Time was their weapon, their advantage, the factor that allowed smaller numbers of experienced pilots to remain effective against overwhelming numerical odds. Now that weapon had been taken from them. The Americans could stay. They could escort all the way to the target and back. They could loiter over Germany, looking for opportunities to engage German fighters on favorable terms. The Luftwaffe would have to fundamentally rethink how they defended German airspace, and they would have to do it quickly. German fighter commanders recognized immediately what had changed. General Adolf Galland, the Luftwaffe's general of fighters, received reports from unit commanders throughout the Reich defense system describing the same phenomenon. American escorts staying longer, remaining over targets, denying German fighters the opportunity for unopposed attacks on bomber formations. Galland understood the implications. The Luftwaffe was now forced into a battle of attrition they could not win. They lacked the pilot replacement capacity, the fuel reserves, and the aircraft production to sustain a daylight air war where every mission meant fighting not just bombers, but their escorts as well. The industrial disparity that made this possible was staggering when examined in detail. American factories were producing drop tanks at a rate exceeding 100,000 per
month by early 1944. The tanks were treated as expendable one-use items. Pilots dropped them over Europe and new tanks were installed for the next mission. This approach, using massive industrial capacity to solve tactical problems through sheer volume of materiel, was fundamentally different from German practice. The Luftwaffe reused equipment, salvaged parts, and conserved resources because they had to. The Americans threw away fuel tanks by the thousands because they could manufacture more faster than they could be used. The P-51 Mustang, entering service with the 8th Air Force in late 1943 and early 1944, would compound the Luftwaffe's problems exponentially. The Mustang had better internal range than the P-47, achieving a combat radius of approximately 450 miles without external tanks. With two 75-gallon drop tanks, that radius extended to approximately 650 miles, enough to escort bombers to any target in Germany and to many targets in occupied Eastern Europe. The Mustang was also faster than the FW-190 above 25,000 feet, more maneuverable at high altitude, and could outclimb German fighters in the thin air where bomber formations operated. By March 1944, the combined effect of drop tank-equipped P-47s and P-51s fundamentally shifted the balance of the air war. The 8th Air Force launched a series of missions targeting the German aircraft industry, missions historians would later call Big Week, that demonstrated the new reality. American fighters escorted bombers to targets across Germany, engaged Luftwaffe fighters throughout the mission profile, and inflicted unsustainable losses on German fighter units. The Luftwaffe lost over 300 fighters during Big Week, not primarily to bomber defensive fire, but to American escort fighters that could now hunt German aircraft throughout German airspace. The Luftwaffe pilots who survived these encounters described a sense of being hunted rather than being hunters. Where they had once positioned themselves advantageously and waited for escorts to leave, they now faced American fighters that could pursue them, that had the fuel to chase them back to their airfields, that could loiter over known Luftwaffe bases and attack German aircraft during takeoff and landing when they were most vulnerable. The initiative had shifted completely. The Luftwaffe was now reacting, defending, trying to survive, rather than executing coordinated attack plans against bomber formations. The months following January 1944 witnessed the systematic dismantling of the Luftwaffe's ability to defend German airspace. The drop tank, that simple metal or paper container of fuel, had broken the tactical stalemate that had allowed Germany's fighter force to remain effective despite numerical inferiority. What followed was not a single catastrophic defeat, but rather a grinding attrition that the Luftwaffe could not survive.
Every mission now meant fighting American escorts from the moment bombers entered German airspace until they departed. Every engagement consumed pilots, aircraft, and fuel that Germany could not adequately replace. The statistics tell the story with brutal clarity. In January 1944, the Luftwaffe lost approximately 300 fighter aircraft in combat over the Reich. In February, losses exceeded 400 aircraft. During Big Week in late February, when the 8th Air Force launched coordinated strikes against German aircraft production facilities, the Luftwaffe lost another 300 fighters in just 6 days of intensive combat. These were not just machines, but experienced pilots, men whose training and combat knowledge represented years of investment and irreplaceable experience. German pilot training programs could not keep pace with losses. Where American pilot training took approximately 18 months and included hundreds of hours of flight time before assignment to combat units, German training by 1944 had been compressed to bare minimums. New Luftwaffe pilots arrived at frontline units with perhaps 60 hours of total flight time, minimal gunnery training, and almost no experience in formation flying or combat tactics. These men were thrown into battle against American pilots who had completed extensive training programs and often gained additional experience before facing first-line German units. The fuel situation compounded every other problem. Germany's synthetic fuel production, already strained by the demands of a multi-front war, became a primary target for Allied bombers. As refineries and synthetic fuel plants were destroyed or damaged, the Luftwaffe's fuel allocation decreased month by month. By mid-1944, fuel shortages forced the cancellation of training flights, limited operational sorties, and sometimes grounded entire units despite having serviceable aircraft and available pilots. The Luftwaffe was being strangled not through lack of courage or tactical skill, but through simple material exhaustion. Fighter production actually increased through 1944 despite Allied bombing. German industry, dispersed and hidden in small factories and underground facilities, continued producing Bf-109s and FW-190s at impressive rates. The problem was never aircraft availability, but rather the inability to train pilots, the lack of fuel to fly them, and the impossibility of coordinating effective defense when American fighters could range throughout German airspace at will. Germany produced approximately 25,000 single-engine fighters in 1944, more than any previous year of the war. But those aircraft couldn't reverse the fundamental imbalance created by American range advantage and numerical superiority. Luftwaffe fighter units adopted increasingly desperate tactics. Some units concentrated in large formations, attempting to mass sufficient force to overwhelm local American fighter cover and reach the bombers. These Gefechtsverband formations sometimes numbered over 100 aircraft, creating impressive displays of force but proving unwieldy and vulnerable to coordinated American counterattacks. Other units developed specialized Sturmgruppen, equipped with heavy cannons and additional armor, designed to close with bomber formations and accept heavy losses in exchange for bomber kills. These units achieved some successes but suffered catastrophic casualty rates that made them unsustainable. The Me-262 jet fighter, entering limited service in mid-1944, offered technological superiority but came too late and in too few numbers to affect the strategic situation. The jet's speed advantage allowed it to engage bombers with minimal exposure to escorts, but production problems, fuel shortages, and Hitler's initial insistence that the aircraft be configured as a bomber delayed its deployment and limited its impact. By the time Me-262s were available in meaningful numbers, the Luftwaffe lacked the fuel, the trained pilots, and the operational infrastructure to employ them effectively. The individual cost of this transformation was measured in thousands of lives, German and American, but the nature of those costs differed fundamentally between the two sides. American bomber crews, flying missions deep into Germany throughout 1944 and into 1945, faced lethal danger on every sortie. Flak remained deadly regardless of fighter escort. German fighters, when they penetrated the escort screen, could destroy bombers with terrifying efficiency. Mechanical failures, weather, and simple bad luck killed men who never saw an enemy fighter. But the presence of escorts throughout the mission profile reduced losses from their peak rates of 15 to 20% down to sustainable levels of 3 to 5%. More American crews survived to complete their 25 mission tours and return home. For Luftwaffe pilots, the cost was existential. The veteran pilots who had survived since 1940, who had flown in France, Britain, Russia, and now over Germany itself, watched their units fill with inexperienced replacements who died in their first or second missions. The veterans themselves faced odds that grew worse with each passing month. American fighters were everywhere, not just over targets, but hunting throughout German airspace, attacking airfields, strafing trains, shooting up any aircraft they encountered. Luftwaffe pilots who managed to take off, engage the enemy, and land safely had to do it all again the next day and the day after, until statistics inevitably caught up with them. Oberleutnant Heinz Knoke, whose diary entry about Oschersleben captured the moment of realization, continued flying missions throughout 1944. He survived the year, one of the relative few experienced pilots to do so, but his unit was decimated. Of the pilots he had flown with in January, most were dead by December. His diary entries from late 1944 reflect exhaustion, resignation, and a grim determination to continue fighting despite knowing the war was lost. He was shot down twice more, wounded, and eventually grounded due to injury in March 1945. He survived the war, but most of his comrades did not. The American pilots who flew those escort missions experienced their own costs, though of a different character. Combat fatigue was real and cumulative. Watching friends die, flying through flak that could kill you randomly regardless of skill, engaging in high-speed aerial combat, where a moment's inattention meant death, all took psychological tolls that didn't always show in casualty statistics. But American pilots knew they were winning. They could see the evidence in every mission. German fighters becoming scarcer, opposition less coordinated. The Luftwaffe's ability to contest American air superiority visibly declining month by month. The drop tank itself, the simple technology that catalyzed this transformation, remained in use for the rest of the war. Production continued at high rates, with contracts placed with dozens of manufacturers to ensure adequate supply. The tanks evolved slightly, with improvements to reliability and fuel feed systems, but the basic concept remained unchanged. They were simple, expendable, effective. Thousands of them fell from American fighters over Europe, littering the landscape from France to Poland with metal and paper cylinders that had served their purpose and been discarded. Post-war analysis by German military historians identified the advent of drop tank-equipped American escorts as one of several decisive turning points in the air war over Europe. Combined with increasing American numerical superiority, the introduction of the P-51 Mustang, and the progressive destruction of German fuel production, the drop tank helped create conditions under which the Luftwaffe could not effectively defend German airspace. General Galland, in his post-war memoir, The First and the Last, identified the period from January through March 1944 as the point when the air war over Germany was effectively lost, when the combination of American technical solutions and overwhelming material superiority made continued effective defense impossible. The psychological dimension of this defeat deserves particular attention. The Luftwaffe in 1944 was not the Luftwaffe of 1940. It was tired, worn down by years of combat on multiple fronts, suffering from fuel and pilot shortages, increasingly led by inexperienced commanders as veterans died or were promoted away from operational units. But it still retained combat effectiveness and could have prolonged the air war substantially if American fighters had remained range-limited. The drop tank eliminated the one tactical advantage the Luftwaffe could still exploit: time. Once that advantage disappeared, once American fighters could stay as long as necessary, the outcome was inevitable. What remained was the grinding process of attrition that killed thousands more men, but changed no strategic realities. The Battle of Oschersleben on January 11, 1944, was not the largest air battle of World War II. It was not the bloodiest. It produced no dramatic turning point that contemporaries immediately recognized as decisive. The bombers struck their target, some aircraft were lost, pilots on both sides died, and the war continued. But in that mission's execution, in the simple fact that American fighters remained over Germany for hours rather than minutes, the Luftwaffe's veteran pilots recognized something their commanders would take weeks to fully acknowledge. The equation had changed irreversibly. The drop tank represented American industrial warfare at its most characteristic. Faced with a tactical problem, the range limitation of escort fighters, American planners and engineers developed a technical solution that was neither elegant nor sophisticated. They didn't redesign fighters from scratch or develop exotic new propulsion systems. They simply carried more fuel in throwaway containers, and they produced those containers in such quantities that every fighter on every mission could be equipped with them. The solution worked because American industrial capacity could support it, could manufacture millions of drop tanks, could treat them as consumable items to be discarded after single use, and could sustain that level of production for years. The Luftwaffe had no equivalent answer. Germany's industrial capacity, impressive by any measure except when compared to America's, could not match this approach. German engineers designed drop tanks for Bf-109s and FW-190s, but production remained limited, and the tanks themselves were often retained and reused rather than discarded. German fighters occasionally flew with external tanks, but not systematically, not on every mission, not in numbers sufficient to fundamentally change operational capabilities. The disparity reflected broader differences in industrial capacity, resource availability, and strategic priorities. What the Luftwaffe pilots discovered over Oschersleben, they would experience repeatedly over the following months across hundreds of missions. The Americans could stay. They had fuel to burn, literally, discarding thousands of gallons worth of drop tanks over Europe every week. They had fighters in numbers that seemed inexhaustible. They had pilots arriving from training programs that produced more replacements than losses consumed. They had coordination through radio equipment installed in every aircraft, allowing tactical flexibility the Luftwaffe couldn't match with its radio-limited formations. They had, in short, material superiority so complete that tactical skill and combat experience couldn't overcome it. The men who died in those battles, German and American both, died fighting the war as they found it, not the war as it might have been under different circumstances. Luftwaffe pilots climbed into their fighters knowing they faced overwhelming odds, knowing their fuel was limited and their opponent's was not, knowing their training was inadequate, and their equipment stretched beyond sustainability. They flew anyway because that was their duty, their mission, and their commitment to comrades and country. American pilots climbed into their fighters with better odds, but still faced lethal danger on every mission, still died when fighters got through the formation or flak found their aircraft, still demonstrated courage, even when fighting from a position of material advantage. The story of the drop tank is not a story of technological brilliance or tactical genius. It's a story of industrial capacity applied to military problems, of material superiority translating into operational advantage, of simple solutions implemented at massive scale. It's a story that illustrates a fundamental truth about the Second World War in Europe. Germany faced opponents who could outproduce them in every category of war materiel, who could sustain losses that would cripple German forces, who could solve tactical problems through sheer volume of resources applied to solutions. That afternoon in January 1944, when Luftwaffe pilots watched American fighters remain over Germany hour after hour, they were witnessing this truth in its most concrete form. Those drop tanks hanging beneath P-47 wings represented not just additional fuel, but the industrial might of a nation that could afford to throw away metal and paper cylinders by the thousands. The psychological impact of that realization, the understanding that the enemy's material advantage was so complete that they treated as disposable what you would carefully husband and reuse, was as devastating as any combat loss. The air war over Europe continued for another 16 months after Oschersleben. More men died, more aircraft were destroyed, more missions were flown. The strategic bombing campaign achieved its objectives, not primarily through the physical destruction of German industry, but through forcing Germany to allocate enormous resources to air defense, resources that might otherwise have supported ground forces on the eastern and western fronts. The Luftwaffe, ground down through attrition it could not sustain, ceased to be an effective force by late 1944, leaving German cities and armies vulnerable to air attack. When the war ended in May 1945, among the millions of pieces of debris scattered across Europe were thousands of drop tanks, some intact, most damaged or destroyed, all of them serving as small metal monuments to the industrial capacity that had helped win the war. They were simple objects, these fuel tanks, unremarkable in isolation. But in aggregate, in the millions of gallons of fuel they carried, in the hours of combat endurance they provided, in the tactical advantage they conferred, they represented one of the decisive technologies of the air war, not because they were sophisticated, but because they were simple enough to be produced in quantities that overwhelmed any possible German response. The Luftwaffe pilots who encountered drop tank-equipped American escorts that January learned a lesson that would be validated over and over in the months that followed. The mathematics of material warfare are unforgiving. Courage, skill, and tactical knowledge matter, but they cannot overcome numerical and material disadvantages beyond a certain threshold. That threshold was crossed definitively in early 1944, when American fighters gained the range to escort bombers throughout their missions over Germany. What followed was inevitable, a conclusion determined by industrial capacity and resource allocation, as much as by any action taken by individuals in combat. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.